Welcome to Pre-Calculus Lesson 2.5, Rational Functions. Student Notes Part 1. The learning target for this part of the lesson, for Lesson 2.5, is that you can solve rational equations. It's important to note that just like with radical equations, we must always remember to check for extraneous solutions. Extraneous solutions are not introduced when we're just solving polynomial functions, like in lesson 2.4. But in lesson 2.1, when we had radical functions and we were squaring them, we introduced some extraneous solutions. In 2.5, when we multiply by the least common denominator to clear the denominator, we possibly introduce extraneous solutions. So when we get our answers, we have to make sure to check. A rational function. A rational function is defined as a function f of x equals p of x over q of x. Where p of x and q of x are polynomial equations or polynomial expressions. To solve a rational equation, as you did in Algebra 2, we go through a series of at least 4 steps. The 4 main steps are as follows. The first is to find the least common denominator of all terms. The second step is to multiply each term by the least common denominator and simplify. So we're going to multiply each numerator by the least common denominator and simplify the fraction. Our third step will be to solve the remaining equation. And our last step, very important, check for extraneous solutions. We're going to take a look at this with the first example, letter A. There are 4 terms. On the left side there are 2 terms, on the right side there is 1. We're going to find the least common denominator of all of these. Right now this is over 1 and this is over 1. The least common denominator of this one is x plus 3. I'm going to multiply every numerator by x plus 3, the factor x plus 3 in parentheses. Then I'm going to go and simplify each expression. On my first term, I notice that I have a factor of x plus 3 in the denominator and in the numerator, so they cancel. I'm left with 20. I want to be careful here because it says minus 4, so I'm going to do plus a negative 4 to make sure that I distribute that negative with the 4. Negative 4 gets distributed into the x plus 3, giving us negative 4x minus 12. That's the left-hand side of the equation. On the right-hand side, I have 0 times x plus 3, which is still 0. I'm going to combine like terms now because I'm solving the remaining equation. That is 8, so negative 4x plus 8 equals 0. I'm going to take away 8 from both sides. Opposite of 4x equals negative 8. By dividing by negative 4, I get that x equals 2. There's my solution to this equation. I'm going to check for extraneous solutions by putting the left side of the equation in for y sub 1, making sure that any factors or any addition or subtraction in the numerator or denominator, if there is, I make sure to put that entire numerator or denominator in parentheses. And that was originally a minus 4. On the other side was 0. So now when I go to my table and plug in my answer of 2, I get that it does equal 0 for both sides. So this is the correct solution. Another thing I have to be careful about to consider is the domain. For this equation, we cannot have a value of x equals negative 3. So had I gotten that as one of my solutions, it would definitely have been extraneous. In letter B, first off, as I go to find the least common denominator, since that's the first step, I need to make sure that I have this every denominator in factored form. In factored form, this is x minus 4 and x minus 2. When I go to find my least common denominator, I can see that I have a common factor of x minus 2 and a common factor of x minus 4. So I'm now going to multiply every term on both sides by x minus 2 by x minus 4. When I go to do that on the left side, I have a factor of x minus 2 in the numerator and in the denominator. Those cancel. X minus 4, both factors in the numerator and denominator, those cancel. I'm left with 4. On the right side of the equal sign, when I go to, before I multiply out, I go to simplify my fraction. I have a factor of x minus 2 in the numerator and denominator. So all I need to do is 3x times x minus 4, which is 3x squared minus 12x. And with the last term, a factor of x minus 4 is in the denominator, so that factor cancels in the numerator. I'm left with 2 times x minus 2, which is 2x minus 4. When we combine like terms, we have 4 equals 3x squared minus 10x minus 4. This is a quadratic. We did not see a quadratic in the original equation, so by multiplying by this least common denominator, we may have introduced extraneous solutions. We'll have to check at the end. I'm going to take away 4 from both sides to get the quadratic equal to 0, and I'm hoping that it's factorable, but if it's not, I'll use the quadratic formula to solve it. So now, I should be able to factor this. 3x times x, and 2 would give me 6, and 4 would give me 4. 6 and 4 can add to 10 if they're, it needs to be positive and negative though. That's the problem, hold on. I switched my terms, so now I have 12x and 2x. I'll have a negative 12x and a positive 2x adding the negative 10. Positive 2 and negative 4 still multiplying the negative 8. Setting each factor equal to 0, I get x equals negative 2/3. Or x equals 4. Now this is the solution to the quadratic equation we built in our attempts to solve the rational equation. We're going to have to plug in the left side of that equation, making sure that our denominator's in parentheses since it has multiple terms. X squared minus 6x plus 8. And then the right side of the equation, 3x over, in parentheses, x minus 2. Plus 2 over, in parentheses, x minus 4. When I go to my table and plug in negative 2/3, I get the exact same decimal value on both sides. So I know that that's a solution. When I plug in 4 though, it's giving me an error. The reason why is that for this fraction right here, it's an undefined value. So the domain of this is that x cannot equal 4. So x equals 4 is extraneous. X equals negative 2/3 is the solution to the rational equation. Looking at letter C, the least common denominator is x minus 8, so I'm going to multiply every single term by x minus 8, except I actually don't multiply it through on the second term because I have the same factor in the denominator canceling it out. This first term gives me x squared minus 8x plus 6. 0 times x minus 8 is 0. I'm going to factor this quadratic, x minus 4 by, has to multiply to 6. There are no factors of 6 that will add to negative 8, so we are going to have to solve by quadratic formula. So I have the opposite of b, plus or minus the square root of the discriminant, which is b squared, minus 4 times a times c, which is 40, each over 2a. This reduces to 4. Square root of 40 is really the square root of 4 and the square root of 10, which is 2 square roots of 10. When put over 2 is just the square root of 10. So my solutions are 4 plus the square root of 10 and 4 minus the square root of 10. But we're going to plug those in and see if they actually work. So on the left side of this equation, I have x plus 6 over, in parentheses, x minus 8. Wait, I don't think I did that right. It was supposed to be x plus 6 over, in parentheses, x minus 8. On the right side of the equation, I have 0. I don't think these are going to work, but let's put them in. 4 plus the square root of 10. Wow, it actually worked. And 4 minus the square root of 10 also worked. So there are no extraneous. These are the solutions to this equation. Looking at letter D, here is the equation. Again, it's not in factored form, so we're going to factor the right-hand side, giving us, in this case, x minus 6 by x plus 3. It worked out nice that they were the same factors. My least common denominator then is x minus 6 by x plus 3. So I have a common factor and a common factor. We're going to multiply every term by that least common denominator. But before I start multiplying through, it's a minus 6. Before I start multiplying through, I'm going to make certain that I cancel out any common factors in the numerator and denominator. So here, the x plus 3 is gone. I have 2x by x minus 6. You can write that out if you want. It's going to give us 2x squared minus 12x. Here, I have a common factor of x minus 6, so that cancels. And I'm left with 3 times x minus 3. I had addition, so I didn't have to distribute a negative or anything. It's going to give me plus 3x minus 9. On the other side of the equal sign, we have both the factors of x minus 6 and x plus 3 canceling, leaving us with just 27. When we combine like terms on the left side, it gives us 2x squared minus 9x minus 9, but I'm going to take 27 away from both sides to get it equal to 0. 9 minus negative 27 is negative 36. There's no greatest common factor of those 3 terms, so I'm going to try to factor. Hopefully it will. 2x by x. 6 and 6 won't work. Well, that's 12 and 6. 4 and 9 would be 8 and 9, which is not going to give us 9. 36 divided by 2 is 18. 18 and 2, that could work. 18 and 2, no, because that's going to be 4. All right, I'm not seeing if it's factorable, so I'm going to check the discriminant just to see. It might just be me. Maybe I'm not thinking of the factors correctly. B squared minus 4 times A times C, make sure you include the signs, is 369, which is not a perfect square, so